Hello, this is Professor Jianmei Chen at California State University, Long Beach. In this video lesson today, we'll look at solving absolute value equations and inequalities. The absolute value of a number a, which is denoted by the two vertical bars around it, is the distance from the point a to 0 on the real number line. For example, if I ask you what absolute value of -7 is, it's essentially asking what is the distance of -7 away from 0. Well, clearly -7 is 7 steps to the left of the origin, so the answer is +7. This can be seen on the real number line. If you label the origin 0 and then you label the number -7, it's obvious that -7 is 7 steps away from the origin. There's another point on the real number line that is 7 units away from the origin as well, and that is 7 steps to the right of the origin, which gives you +7. And I can denote that as the absolute value of +7 is equal to +7. You notice that regardless whether or not we start with a positive number or a negative number inside the absolute value, the answer comes out to be positive all the time. On the other hand, if you actually have the absolute value of 0, well, that is saying the point 0 is 0 distance away from the origin. So the absolute value of 0 is always going to be equal to 0. There's a characteristic of the absolute value function is that the result is always going to be positive or 0. We can capture that in the following definition. We say the absolute value of a number a is either going to be just a number a if a is already positive or equal to 0. Now if a is a negative number to start with, and after you take the absolute value, it's going to turn it into positive. So that means taking the opposite of its original value. So if a is less than 0, which is a negative number to start with, then the effect of taking the absolute value on it is going to turn it into a positive quantity. So this is the formal definition of the absolute value function. This notion of distance can be extended to general points on the real number line. If I ask you what would be the distance between any 2 points A and B on the real number line, well, graphically it's this quantity right here, and how do we actually capture that in the notation? Well, we just say that the distance between point A to point B is simply given by the absolute value of the difference between the two. Now, does it matter if I take B minus A first, or I take A minus B? It turns out that they're exactly the same because if you do B minus A, it gives you a positive quantity because B is greater than A. If you do A minus B, you actually get a negative quantity. But after you take the absolute value on that, it's going to turn into a positive quantity anyways. So really, these two are exactly the same thing. Here's a quick example. If I ask you to find the distance between the point -8 and 2, well, you can either do 2 minus the -a, which in this case will give you 10 in the absolute value. But after you take the absolute value, that's just going to be +10. Or you can do the absolute value of -8 minus 2, which then gives you the -10 in the absolute value. But by the definition, you're just going to take the negative of that number, right? Because if your number that you started with is a negative quantity, then you need to put a negative sign in front of it to turn it into a positive. So either way, you get the same thing. Next, let's consider a few questions. If I ask you, what does solving the absolute value of x equals 3 mean? What would you say? The solving the equation the absolute value of x equals 3 means getting all points on the real number line that are at a distance of 3 from the origin. Well, what are they? If this is the origin, and you're counting 3 steps away from it, you can either go to the right or you can go to the left. If you go to the right 3 steps, 1, 2, 3, you would land at the unit 3. If you go to the left 3 steps, then you will land at the point -3. So essentially there are 2 points that are 3 distance away from the origin, namely the number 3 or -3. If we write that in a set builder notation, we will write it as a set of all x such that x is either 3 or -3. A simpler way of writing that would then be using the plus or minus sign. So I can write it as x equals plus or minus 3. Now that we're a little bit more familiar with what the absolute value function means, let's look at this next example. What is solving 3 times the absolute value of x minus 7 plus 5 equals 14 mean? It's actually a little difficult to interpret what this equation means from its original form. So let's convert it into a similar equivalence equation first. Manipulating an equation that involves absolute value is exactly the same as manipulating any linear equations that has x in it. We first identify where the location of x is and try to isolate that term on one side of the equation. So in this case, I'm going to try to get rid of the 5 on the left hand side first. Namely, I'm going to subtract 5 both sides. The result of doing that gives me 3 times the absolute value of x minus 7 equals 9. And then I'm going to try to isolate the x minus 7 term by dividing out the 3 both sides. Next, I have the absolute value of x minus 7 equals 3. Once we get to here, it is much easier to interpret what this equation means. This equation actually means the distance between the quantity x minus 7 and the origin 0 is 3. Next, you ask yourself the question, where on the real number line will then be 3 units away from 0? Well, it's going to be either positive 3 or negative 3, which means the quantity x minus 7 could be set to be 3 or negative 3. So we actually have 2 cases to consider here. Case 1, we have x minus 7 equals positive 3. Case 2, we have x minus 7 equals negative 3. In either case, we're just going to go ahead and solve for x. So in case 1, just add 7 both sides, we get x equals 10. In case 2, we just add 7 both sides to get x equals 4. These are actually connected by an OR statement, because it could be either 10 or 4. A point cannot be simultaneously 10 and 4 at one time, so it has to be connected by an OR statement. So the solution to this equation that involves absolute value would then be in set builder notation the set of all x such that x is 10 or x is 4. Next, let's ask a different questions. Instead of writing a absolute value equations that involves just the equal sign, let's consider one with inequality sign in it. For example, what does solving the absolute value of x greater than 3 mean? In this case, we're looking for points on the real number line whose distance from the origin is greater than 3. So you ask yourself the questions, where could those points be located? Well, if here is 0, and this is 3 and negative 3, and we know at those 2 points, you're exactly 3 units away from the origin. Now we want it to be greater than 3, which means you gotta either go to the right of 3, or you gotta go to the left of negative 3 to get those points, right? So your solution set would then contain all points that are less than negative 3 or greater than positive 3. So in set builder notation, we will write this as the set of x such that x is greater than 3 or x is less than negative 3. Or if you want to write this in interval notation, you would write it as a negative infinity to 3, open bracket, union 3 to positive infinity and open bracket in both ends. On the other hand, what does solving the absolute value of x less than 3 mean? Well, it means to find points on the real number line whose distance from 0 is less than 3. So again, if you look at this picture where you start with the origin 0, and you label the points that are exactly 3 units away from 0, which are negative 3 and 3, and you're looking for points that are within that range. So it has to be basically trapped in here. And to describe this in a set builder notation, we would say this is a set of all x such that x is strictly greater than negative 3 and strictly less than 3. Or in interval notation, it would be negative 3 to 3, both open brackets. We can now extend these ideas to more general cases. For example, let's solve the inequality. Absolute value of 3x plus 2 is greater than or equal to 4. We'll first try to interpret what this means in words, and then solve it mathematically. This inequality basically means that the quantity 3x plus 2 is 4 units away from the origin. Well, where are the points that are 4 units away from the origin? If here's 0, and this is negative 4, and this is positive 4, These are the points that are 4 units away from the origin, and these are the points that are at least 4 units away from the origin. So what we need to do is to set the quantity 3x plus 2 to be either greater than or equal to 4 or less than or equal to negative 4. In the first case, just to solve it, we have 3x greater than or equal to 2, where we subtract 2 both sides, and then divided by 3 the next step. We will get x greater than or equal to 2/3. On the second case here, we subtract 2 both sides as well to get 3x less than or equal to negative 6. And then we're going to divide it by 3 both sides to get x less than or equal to negative 2. We can then combine these two cases into our solution set. We can write our solution set in the set builder notation as the set of all x such that x is greater than or equal to 2/3, or x is less than or equal to negative 2. The interval notation, we will write this as a close bracket, 2/3 to infinity, union, the open bracket, negative infinity, negative 2, close bracket. The reason why I know to use the union symbol is because it is an or statement. Next, let's try to practice what we've learned in an application problem. Consider example 5 in section 1.9. The problem states, the specifications for a car engine indicate that the pistons have diameter 3.8745 inches, with a tolerance of 0.0015 inches. This means that the diameters can vary by as much as 0.0015 inches and still be acceptable. First, we want to find the inequality that involves absolute values that describes the range of acceptable diameters for piston. The way we're going to do that is by considering what's the largest diameter that is acceptable and the smallest that's acceptable, and try to deduce from that to get an inequality going. So try to answer this box here, if you will, by yourself. Okay, so if you ignore my very ugly drawing of a circle, the diameter is 3.8745 drawn in a picture here. The tolerance being 0.05 means that you can actually extend in all directions by that much. So I can actually draw a little bit bigger circle here so that the extension does not exceed the 0.0015 inches. So by looking at this picture, you can then hopefully answer this question. What is the largest diameter of the acceptable piston? Well, it's going to be the original 3.8745 plus this extra much that is acceptable, which is 3.8760. But you can also go the other way, right? You can actually make it bigger or make it smaller. So you can actually have a smaller circle inside the red here with the tolerance being the 0.0015 again. So if you go the other way, then that's the smallest diameter of acceptable piston, which would be 3.8745 minus the 0.0015, which then you would get 3.8730. So the acceptable tolerance would be basically everything in between, from the smallest to the largest. Now, how do you actually capture that in an absolute value inequality? Well, pictorially, this is what we want to say. If we label this as a 3.875 as the original piston diameter you started with, then the distance of an allowable diameter to that 3.875 should not exceed 0.015. So that means the distance between this number here and the 3.875 should less than or equal to 0.0015. So if you cast that in an absolute value equation, I would write this as d minus 3.875 is less than or equal to 0.0015. Now if you go ahead and solve this inequality by first taking away the absolute value sign, we can rewrite this as d minus 3.875 is less than or equal to 0.0015, or it could actually be greater than or equal to the negative 0.0015. And then solving this inequality simultaneously involves simply just adding 3.875 to every single side of inequality, which would give us the desired answer. 3.8730 is less than or equal to d, which is then less than or equal to 3.8760. So in words, this means that acceptable piston diameters may vary between 3.8730 inches and 3.876 inches, which is also equivalent to say that the diameter of the acceptable piston is 3.875 plus or minus 0.0015. And that's it.